In this video, you're going to learn about closures in JavaScript. Closures closely relate to function and function scope, so what we're going to do is explore exactly what they are and how they work. Now, the good news is that you've actually already worked with closures in this course, you just didn't know it. We didn't have a term to describe what we were doing. In this one, we're going to go through a few examples, figuring out exactly how and why they work. Now, all of this closely relates to functions, so for this one, we're not going to worry about the Hangman application. We're just going to make a new file in the functions directory. Right inside of here, we can call this one closures, since what we're going to be working with closely relates to the function. We're going to run through a couple of examples, just running them through Node, then we'll move on to the next video and get back to asynchronous programming. Let's go ahead and kick things off with a relatively straightforward example of a closure. So right here, that's going to be const my function, and we're just going to define a function. We can create it as an arrow function, that's perfectly fine. Then down below, we're going to call it, calling my function. Now we're going to put some stuff inside of my function to actually run. The first thing we're going to do is create a const. I'll make a const called message, and I'll set it equal to a string message. This is my message. Very exciting message. Excellent. Now down below, what we're going to do is create another function. So const, I'm going to call this one print message, and I am going to set this equal to an arrow function. And all we're going to do inside of print message is print the message from up above. So console.log, printing the message. And the last thing we're going to do inside of my function is to call print message. Right here, I'm going to call print message awesome. So this is a relatively straightforward program. We define a function and we call it. The function creates a variable, creates another function, and then calls that function. The function inside of here, print message, just prints this variable's value to the screen. If we go ahead and save closures, we can prove that this works. I'm going to run it from the terminal. Let's go ahead and create a brand new tab in JS Bootcamp. Then I'm going to cd into the functions folder. And from here, we can use node closures.js to execute the script. What happens? Exactly as we described, we get this is my message printing. So this is at its very basics an example of a closure, but this one's a bit too straightforward to see where closures actually become useful. So I want to make a small tweak to this. Instead of calling print message right here, we're going to return print message. So return print message. Then down below, we're actually going to access that return value. I'll just store it on a variable. Const my print message. So I'm calling my function, I'm getting print message back, I'm storing it in this variable, then I'm just going to call that variable as a function, which it is. Right here, my print message, passing in no arguments because the function defined up above takes no arguments. Now if we go ahead and run the program, we can see what happens. I'm going to save the script. I'm going to rerun it. What do we get? Right here we get our message. This is my message printing exactly as we did before. Now this behavior might either seem normal or very strange depending on your previous programming experience. If you come from another language that supported or didn't support closures, this behavior is either going to look very normal or very foreign. Let's go ahead and break down exactly what's happening here and why it's special. The first thing that's worth noting is that we don't call print message until after my function has returned. And this is obviously true because we use the return value from my function to access print message. There is no way we could have ever called this function until this function has completed. Now what's interesting though is that even though we call my print message down here after my function is done, print message still works. Our function right here still has access to the message variable from the parent function. So this is a closure. A closure is the combination of a function with the lexical scope in which it was defined. In this case, when print message was defined, it had access to message, so it's always going to have access to message, even if my function completes. Now, this behavior might not seem particularly fascinating at the moment, but we don't have to look far in order to run into examples of where we've already used closures. If we go over into the requests.js file, what do we have? We have a function getPuzzle and a function getCountry. Both of them use add request listener to set up a callback function that gets fired later when the HTTP request completes. Now we know that it takes time for an HTTP request to complete, maybe 50 milliseconds or something along those lines. This is much longer than it'll take for getPuzzle to finish. So getPuzzle and getCountry actually complete, then at some point down the line, these callback functions fire. It is because of closures that this inner function has access to callback. So because we have a closure, our function has access to the lexical scope in which it was defined. In this case, it had access to callback. It also had access to word count. It just happened to not use it. Down below, we can see that word count was used outside of that function, but it could have used it had it wanted to. So using closures and actually having support for them is essential for patterns like this to actually work. Without it, we wouldn't be able to do the stuff we've already been doing. Now, this is just one simple example to illustrate where a closure comes up. I want to take a look at a couple of other common closure examples to give you a bit more of an idea of where they can be useful. Let's go ahead and kick things off by deleting everything we have so far, and we're going to look at how we can use a closure to create a way to have a private variable in JavaScript, a variable that's only accessible or modifiable via a very specific set of rules. Now let's go ahead and start off by creating a function, const create counter, and we're going to set this one up to store count. So let count equal 0. Now what we're going to do is return a set of methods that allow someone to interact with count in very specific ways. So right here, we're going to return an object, and on this object, we're going to define a few things. I will start with increment. Increment is going to be a method, and we're going to use count plus plus to increment the count by 1. We're also, after increment, going to set up decrement. Decrement is going to use count minus minus to reduce the count by 1. So now we have a way to manage the count by incrementing it or decrementing it. We're also going to set up a way to get the count. I'll just create a method called get, and this is just going to return the count value. Now let's see how this might actually be used, and that's when we're going to figure out why this is useful. Right here, I'm going to create a const counter, then I'm going to call create counter, and what comes back, what we store here, is indeed this object. Now on this object, what do we have? We have a bunch of functions. All of these functions are using closures to access count, a variable defined right here. The end result is that the person who's using our counter tool cannot hack the system. They can only ever increment the count by 1, decrement it by 1, or get it. There's no way to increment the count by 100 to cheat the system. There's no way to change the count variable over to a string. It is only modifiable by a very specific set of methods. Down below, we can go ahead and use those methods. Let's use counter.increment. Then down below, I'll use counter.decrement. And I'm going to go ahead and copy this line, decrementing twice. And then finally, we'll use get. So console.log counter.get. Perfect. So here we're adding 1 to it, then subtracting 2. The end result should be -1. I'm going to save the script, rerun things from the terminal, and that is exactly what we get. Now, the cool thing about using a closure in this way is that I cannot modify the count other than via these two methods. I could try to counter.count equals 0, but that's not the same thing. This is trying to add a property onto the object. At no point do we have access to this variable, even though the variable exists because of closures. Let's go ahead and run this script and see that we get the exact same result. And there we go. We are still getting -1. So using a closure in this way, we are able to create a variable or a set of variables that are only modifiable via the interface we provide. You can't just do anything you want with them. You have to use our methods to actually work with the data. And depending on your application, this could be a very useful thing to be able to do. Down below, we can run through another example to give us a bit more experience. Let's call this one adder. I'm going to create a function called create adder. And this is going to be a function that takes in a single argument a, and we'll set it up as an arrow function. And now all this is going to do is it is going to return a function. And this inner function is also going to take a single argument, and I will call this b. Now the inner function is going to have a single line. I am going to return a plus b. The inner function still has access to a via the closure. And now let's see why this is interesting by actually using it. So down below, to use this, we would create a variable const, and we would call it something like add10, for example. Then we can call createAddr, passing in our base value of 10. Now down below that, we can use add10 to add 10 to any number out there. So console.log, so we can actually see the value. I am going to call add10 passing in any number at all. Let's pass in -2. Then I'm going to take this line, I'll duplicate it down below, and we'll pass in a different number to add 10. Let's go ahead and pass in 20. So in this case, we've used a function to generate a function, and we can call this function as many times as we want to get some work done. If we save the closures file and rerun things from the terminal, what do I get? I get 8, which is 10 minus 2, and I get 30, which is 10 plus 20. Now that we have createAddr, we could actually use it again to create an adder for a different base. So I could create const add 100, and to generate that, I would just call createAddr again, but this time pass in 100 as the base value. Then I can call add 100 as many times as I want to actually add 100. We'll just do it a single time. Let's go ahead and use add 100. I'm going to pass in -90, which should return the value 10. If I run the script, we're looking for the last value that prints. The last value is indeed 10. So this pattern is indeed using a closure to get its job done, but it's also using another pattern worth defining, which is called currying. Currying refers to the process of transforming a single function that takes a lot of arguments to multiple functions that take a subset of those arguments. So the uncurried version of this function would be const add, where we pass in a and b, and then we return a plus b. This was one of the first functions we created in the course that we didn't use the arrow function to generate it. So in this case, we have a standard version. We have the single function that takes in both arguments. Down below, we have the curried version where we've broken it up into multiple functions that each take a subset of those arguments. And this is useful when we want to generate functions with some sort of base value. Now, this adder example is just an example to show you how this works. You're going to be working through a more real-world example down below that's going to require you to use the same techniques that we just covered. Right here, I'll leave a little comment to separate the two examples. This one can be called tipper. So there are 4 steps for completing this challenge. The big picture goal is to create a function that allows you to generate another function, like we did above, where our first function takes in the base tip %, and the second one, the inner one, takes in the amount. So right here, step 1, create tipper, which takes in the base tip. If you want to tip 15%, this would be represented by 0.15. Then step 2, set it up to return a function that takes in the bill amount. So here we have 2 functions that each take an argument, much like we did up above for createAddr. Now step 3 and 4 revolve around using it. You're going to call createTipper to generate a few new functions for different percentages. Maybe I generate one for 15, 20, and 25. I can get the common tip amounts, and then I could do something cool with them. If I was creating software to generate receipts, I could show them on the receipt so people don't have to run the math in their head. They can just pick the amount they want to leave and write that number down. Then step 4 is to actually use those generated functions. So in this case, I might have something like tip 20. I would call tip 20 with a value like 100 for my $100 bill, and I would expect to get $20 back. That's it for the setup. Take some time to knock this one out, test your work, pause the video, and when you're done, come back and click play. How'd that go? Let's go ahead and kick things off together by creating createTipper. Const createTipper equals. This is the function that takes in my base tip. I'm going to set that function up. And inside of this function, all we're going to do is return another one. Return another function, and this is the one that takes the amount. And they can both be arrow functions since I'm not using this and I'm not using arguments. Now what do we do inside of here? I just return the base tip multiplied by the amount, and now we can actually use create tipper. Let's go ahead and generate a couple, one for tipping at 20% and one for tipping at 30%. So const tip 20 equals, we just need to call create tipper, passing in 20, and we'll do the exact same thing for tip 30 below that, calling create tipper, passing in the base tip value, 0.3. This should be 0.2, not 20. Excellent. Now we have our tippers in place, and we can calculate the tip for various bill amounts. Down below, we're going to do just that. I'll use console.log to get these calculated values showing up. I'm going to call inside of console.log tip 20, passing in a number. Let's go ahead and tip on an easy number. I'm going to use 100 so I can run that mental math. Down below that, we're going to use tip 30 on the same amount. So console.log tip 30, passing in 100. Awesome. So at this point, we've created create tipper. We've generated some functions to actually tip, and then we used those to make sure everything works correctly. I'm going to go ahead and remove the challenge comments. We can save our file and rerun things from the terminal. Over here, node closures.js. When I run the script, I care about those last two values. I am getting $20 for the first one and $30 for the second. So there we have it. Everything is working as expected using the create tipper function. And this is just another example of where we can use closures in JavaScript. Now, I talked more about closures and I ran through a few examples because it is an important thing to understand. We're going to be using them a whole bunch more for all of the asynchronous stuff we do. In this case, we are using callback in this inner function. A closure is what makes that possible. So to recap, a closure is the combination of a function, like this one, and the lexical scope in which it was defined. In our case, this function is always going to have access to word count and callback. In this case, we don't happen to use word count, but we do indeed use callback, and we are indeed able to prove that works because our application is correctly sending the puzzle back to app.js, which sits right here. That's where we're going to stop for this one. I'm excited to continue on with asynchronous programming. Now that we know a bit more about how things work in JavaScript, let's jump right into the next one.